Hi viewers, welcome to Learning Electrical Engineering YouTube channel. In this video we will see parallel connection of resistors and current division. For that we will consider a circuit which has one voltage source and two resistors. The connection of the voltage source and resistors are shown in the diagram. The current flowing through R1 will be I1 and the current flowing through R2 will be I2. The currents I1 and I2 can also be called as branch currents. The current delivered by the voltage source will be I, which is marked in the direction. And before proceeding this video, we need to know what is parallel connection. For understanding of the parallel connection, we will take a resistor which is a non-polarity device and it has two terminals. So for identification purpose, we mark for one end is starting end and another end is finishing end. We will apply the same concept to the resistors R1 and R2. So if this is the starting end of R1 and this is the finishing end of R1 and this is the starting end of R2 and this is the finishing end of R2. Now for understanding of parallel connection, the starting end of both the resistors are connected together and further it is connected to the positive terminal of voltage source, and same manner the finishing end of both the resistors are connected together and further it is connected to the negative terminal of the voltage source. The point where the positive terminal and both resistors starting end is meeting, that point we can call it as node A, and the point where the negative terminal of the voltage source and both the finishing end of the resistors meeting, that point we can call it as node B. We need to find out the amount of current flowing through the circuit. For that I need to know the equivalent resistance of the circuit. To find out the equivalent resistance of the circuit, I need to apply Kirchhoff's current law. Kirchhoff's current law can be applied to both node A and node B. But for simplicity purpose, we will take node A. We are going to apply Kirchhoff's current law to the node A. The Kirchhoff's current law is stating that the algebraic sum of the incoming currents and outgoing currents will be 0. For incoming current, I is the incoming current to this node by arrow. By the marking of this arrow, you can take it as positive, and the currents I1 and I2 which are moving away from the node, that is the outgoing currents, we will take it as negative currents. Now we will start to write the equation as per Kirchhoff's current law. At node A, the incoming current is I, so that is the current is flowing towards the node, that is incoming current, so we'll take it as positive. And the currents I1 and I2 which are going away from the node, so this is the outgoing current, so we'll take it as negative, that is I1 minus I2, which is equal to 0. For simplification of this equation, we will transfer the I1 and I2 currents to the right hand side of this equation. So this equation will become I is equal to positive I1 plus positive I2. We know that the Ohm's law, that is I is equal to V by R. Okay, we will apply the value of I here. We know that in parallel connection the voltage is constant, so supply voltage is V and R. I don't know the value of equivalent resistance of this circuit. For equivalent equivalent resistance of this circuit, I'll just write R equivalent. So R equivalent I have written, and the current I1 which is flowing through R1, for the, as I have stated earlier, the voltage across both the resistor will be same, that is V, and amount of current I1 flowing through the resistor R1, so we will write R1 here, and same manner for I2, V by R2. Now further simplification of this equation, V divided by R equivalent resistance is equal to, the common term in both the values will be V, so we will take out V as common, then remaining will be 1 by R1 plus 1 by R2. Now we can cancel out the equal values on both sides of this equation. So remaining will be 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Now I need the value of R equivalent. For that we will further simplify this equation. So the value will be 1 by R equivalent is equal to R. We can cross multiply the values in this manner. So R2 plus R1 divided by R1 plus, sorry, correction, R1 into R2. So this is the value. To obtain the R equivalent value, just we can transfer this equation R equivalent value to the right hand side of this equation, and the right hand side of the equation can be transferred to the left hand side of the equation. So the equation will become R equivalent is equal to R1 into R2 divided by R1 plus R2. So this is the equivalent resistance value. This is the equivalent resistance value of this circuit. Okay, this circuit's equivalent resistance is R1 into R2 divided by R1 plus R2. Now we need to find out the value of I1 and I2 in terms of supply current and the resistances. For that we will take first I1. So I1 is equal to we know V by R1. Now we need to apply V value here, that is the supply voltage value in terms of current and resistance. For that we know V is equal to I into R. Now the value or supply voltage of this circuit will be V and current will be I, and we need to apply the resistance value, that is the circuit equivalent resistance. So circuit equivalent resistance will be this, that is R1 into R2 divided by R1 plus R2. We will write here R1 into R2 divided by R1 plus R2. We will apply the value of I into R1 into R2 divided by R1 plus R2 in place of V. So we can rewrite this equation as I into R1 into R2 divided by R1 plus R2 into 1 by R1. And same manner the I2 value can be find out. We can found I2 will be V divided by R2, which is equal to I into V value. V value is what? This is I into R1 into R2 divided by R1 plus R2 into 1 by R2. From these equations we can say that the value of current I1 is inversely proportional to resistor R1 and I2 is inversely proportional to resistance R2. If you want to find out the value of I1 in terms of supply total circuit total current and resistors, we can use this formula. The equivalent resistance of a parallel combination will be smaller than the smallest resistance in the combination if we are connecting n number of resistors. If n number of resistors having same resistance is connected in parallel combination, the equivalent resistance value will be one resistor resistance value divided by total number of resistances. This will give the equivalent resistance of the parallel combination if n number of resistors having equal resistance or the same resistance is connected. Now we need to note some points for parallel combination. For that, for parallel connection of resistors, we should note some of the points. Those points are: note the voltage across all resistors will be same and current will vary. Current will vary depending upon set branch resistance. Second, the equivalent resistance of a parallel combination will be smaller than smallest resistor connected in the circuit. These 2 points must be kept in mind for parallel combination. If any doubts you are having, please put in the comment box. If you are not subscribed my channel, kindly subscribe it. Thank you.